Okay, so guys, you remember what we were doing? I said the other day that this picture is what I want to talk about. Why am I saying that? It's because it was very hard to figure out where all of these little details went. Especially when you talk about the fact that this picture took 3/4 different fields combining together to make particle physics, quantum mechanics, statistical mechanics, and classical mechanics. So all of those 4 major fields of physics are represented in this one picture. So chapter 11, as we are dealing with, focuses on the rib cage of this picture. So it'll start with systems, the microstates, the ensemble, the distributions, the degeneracy, and the microstates. And then we're going to go towards its wings. We're going to follow the wings into other things. Okay? Okay, so now I used another word called degenerate or degeneracy. No. The word degeneracy is very important in quantum mechanics and classical mechanics, apparently for my class as well. But the concept is kind of hard to understand. So I came up with this example to show you what that word means in very, very simple terms. Gwen, do you remember talking about degeneracy? Do you remember talking about it being really complicated? Or did you not remember?
I feel like it was mentioned.
And the reason why it's very complicated is because conceptually it is very complicated, and most quantum mechanics and statistical mechanics books kind of like push it under the rug. So here's what that word means. So we're still going to define it as G subscript I. But the way I'm going to explain these things to you is by giving you this picture. So if you have an apartment building that has 1, 2, 3, 4 floors, each floor in that apartment building can be considered as an energy level in quantum mechanics or in statistical mechanics. Okay? The number of apartments on each floor is called the degeneracy of the particular floor. Okay? The number of people living in each apartment is called the occupation number. And the energy of this is the number of particles times the energy level of each apartment building. Okay, so does that make sense? So even though the equations are very complicated, but very simply, this is exactly what it is. Each person in your apartment is called the quantum state. A very simple picture? No, let's write this down. So it has how many levels? 4 energy levels, 4 apartment levels. So I will write for this apartment building. May I do that? Okay. I'm going to write this down. Energy levels, so quantum mechanics, and our example. When you hear these words, this is what you should think of. Okay? So our entire system is our apartment building. Okay? Got it? So the word system means the apartment building. The energy level is the floor Can I call them each floor?
Yep.
Each floor, right? So in my example, how many floors are there? And so how many energy levels should I have? E1, E2, E3, E4. So each level, may I call it J? May I call this J like this? Where this is just the number of level. Or apartments on each floor that correspond to it. So the degeneracy, which I called is the number of apartments on each floor. Occupation number, which is NJ, is the total number of people in the apartments. At each level. And the particular quantum state is equivalent to the number of people in one apartment. Okay, now how do I find the total number of particles? In quantum mechanics? No. Total number of particles will be sum over all Nj. And how do I find the energy in quantum mechanics? E will just be Nj, Ej sum, where J just tells me the levels.
That's both cases.
Yeah, both cases. J just tells me the level. So think of this as an apartment high rise. Okay, so going back to this picture. How many energy levels? Good. Corresponding to what energies? 1, 2, 3, 4. What is EV, people? Anyone know what an electron volt is?
Really small number.
It is the what? Yes. No. Good. Attempt it.
No.
Okay. It is the energy that is gained or lost by an electron when it goes through 1 volt. So E is the charge of an electron. V is 1 volt. So it is the energy that is gained or lost by an electron when it goes through 1 volt. So right, if it goes up 1 volt, it will gain that energy. If it goes down 1 volt, it'll lose that energy. That's literally what it is. So can anyone guess what the actual value in the SI unit will be for electron volt? Good. What number? Excellent. What number? Minus 19. Very good. 1 electron, the charge of an electron is 1.6 times 10 to the minus 19. Goes through 1 volt. times those two numbers. So the energy is actually 1.6 times 10 to the minus. Excellent. Good job. And the units will be joules. Woohoo. Okay, so what's the degeneracy of the level 1? How many apartments?
1.
So what's the degeneracy? What's the degeneracy? Okay, I'm gonna make this bigger so we can't cheat. Okay. Okay, so what is degeneracy? The number of apartments on each floor, correct?
Yeah.
So what's the degeneracy of level 3?
3, 4.
Good. What's the degeneracy of level 2?
3.
Okay, now what is the occupation number for level 4? 2. Why is it 2? There's 2 people in there. Okay, what's the occupation number for level 1? 5, right? Okay, so what's the occupation number for level 3? Okay, so what's the occupation number for level 3?
3.
Okay, what if I add another one here from somewhere? Does that make sense?
Yes.
What if this one has another apartment that they make?
Then the degeneracy is 4.
The degeneracy is 4 and the occupation number is?
This 4.
Stay the same, right? It's a new apartment. It just came on the market. Okay. Now, what about the energy? How would you find the energy? So you would take the energy of the level times it by the occupation number. So what's the total energy of level 3? Right now.
1.
So it's level 3 is how many occupied apartments?
4.
And then what's the energy?
3.
So what's the total energy? 12. That's literally all you have to do. So remember, quantum mechanics is not that hard once you figure these things out. It is extremely hard when you just look at this equation and try to figure that out.
Super simple.
But that example is actually very useful. Okay. Also, if there is no other apartment on that floor, that level is called non-degenerate. There is only one possibility for those quantum states to exist. Are we good?
Sure.